trigonometric differentiation. Recall, we have 6 basic trigonometric functions, which include sin x, cos x, tan x, cosec x, cot x, and sec x. So let's look at the 6 trigonometric functions and their derivatives. Good. Trig functions. Trig functions. Derivatives. Trig functions, derivatives. Very good. This is short form of trigonometric. Sin x. Derivative of sin x is cos x. Good. Number 2, cos x. Derivative of cos x is minus sin x. Number 3, tan x. The derivative of tan x is sec square x. Number 4, cosec x. Cosec x. The derivative of cosec x is minus cosec x cot x. Number 5 is cot x. The derivative of cot x is minus cosec square x. Very interesting. The last one, number 6, that is sec x. Sec x. The derivative of sec x is sec x tan x. Very good. Note the following. Sec x means secant. So secant x, and this is what? Reciprocal of cosine. That is 1 over cos x. Very good. The acronym to use here is use the first letter as 1, second letter over this third letter now, cos. So here sec s for 1, the second letter over, now c for cos. So this is 1 over cos x. That's how we got this. Very good. So I have cot x. Cot x means cotangent. Cotangent, and this is 1 over tan x. How? I have c for cot, then cot. C is 1 for over t for tan x. So that is how we got this. Very interesting. It's the best acronym you can use to remember the identities of secant, cotangent, and cosecant. Good. So cosecant now, that is cosec x, that is cosecant. Cosecant. And this is 1 over sin x. So here we are using the first 3 letters of the whole thing. Cosec, this is 1 for over s for sin x. So that is how we got this 1 over sin x. Very interesting. Having known the derivatives of the 6 basic trigonometric functions, let's solve some problems. Very good. Example, if y is equal to tan x squared, find dy dx. Very interesting. What are we going to do? Yes, don't forget tan x, the derivative is sec square x. But this is only when the coefficient of x is 1. The coefficient of this x here is 1. Also when the power is 1. That is when the derivative of tan anything will just be sec square that thing. But if you look at this function to be differentiated here, you can see that the power of x here, the power of x here is not 1, it is 2. So in that case, it will not be sec square x. You have to apply the chain rule, the function of function theory. Very good. Let me recap it. The derivative of tan anything can be sec square that thing if the power of the unknown, whether x or theta, is 1. 2, if the coefficient of the unknown there is also 1. But in this case, the coefficient of x here is 1, but the power is not 1. So it cannot be sec square x square. It is not sec square x square, no, because the power of x here is 2. Very good. So what are we going to do? We apply chain rule. How? Y is equal to tan x squared. Very good. Let u equals x squared. Very interesting. So du dx is equal to 2x. Very good. I applied power of x rule. Having taken the whole of this as u, y is now tan u. Y is equal to what? Tan u. Dy du will be sec square u. Very good. You can see now that I took the derivative of this as sec square u because the coefficient of u here is 1 and the power here is 1. So having known that this is done using chain rule, dy dx is equal to dy du times du dx. Very good. We got dy du as sec square u and du dx is gotten as 2x. Very good. So this is 2x and this is the same as 2x sec square u, but u is x square, but u is what? X square. So dy dx is 2x sec square x square. Very interesting. Thank you.